This morning, this is our Network Admin 8 group. They've worked very hard on the AFP Inc. project. We're going to go ahead and present it to you, and then at the end, I would prefer just to have instructors asking questions, and anything that you have students refer to your instructors after this project is over, all right? So sit back and enjoy.
Good morning, everyone. My name is Gene Jones, and I want to welcome AFP Incorporated. AFP Incorporated is a very dynamic international company. We're doing business in 10 different countries. Their principal business is buying and selling companies depending upon world economic situations. Their assets are in the billions of dollars. Last year, their growth had increased by 25%, resulting in shareholders receiving dividends of $150,000. This kind of growth, and as technology continues to change, and with their 140 plus employees, it was determined that they needed to update their international communication system. The international headquarters for AFP is located in Kansas City, Missouri. We have subordinate offices in Los Angeles, California, and in New York City, New York. They have branch offices in London, England, with subordinate offices in Barcelona, Spain, and in Rome, Italy. We designed and implemented the Windows 2003 environment, which you are about to see. Ben Cutter will explain the network structure. Michelle Weltner will describe the dynamic host configuration protocol. Ben Hockemeyer will describe the routing and remote access service. Next, Dominic Inzarella will describe the domain naming system, and he will also describe the Windows Internet name service. David Hunt will explain the Active Directory structure. Charlie Childress will talk about group policy objects. Then Ty Hill will explain Windows Server Update Service. Brooks Dunham will explain backups and shadow copies. And finally, Michael Gunn will explain the redundant arrays of independent disks and permissions. Ben, it's all yours.
Thanks, Gene. For AFP Incorporated, we chose to utilize the AFP.local private domain name, with each physical location having its own domain. Therefore, we have 6 domains divided into 2 forests, the US forest and the EU forest, with the parent domains being the Kansas City domain and the London domain. The other 4 domains would then be the child domains, and as you can see, the examples of the fully qualified domain names used for each. The IP scheme we chose to utilize was a Class A network. Force is a Class C, so we get a 10.10.x.0/24. Specifically for the US domain, it's the 10. network. The US East domain, New York, is the 20. and LA is the 30. Same exact thing for the EU forest. The EU parent domain is the 110 network, EU East being Rome is the 120, and Barcelona being 130. Within each network, as you can see, they're all pretty much the same setup. We're utilizing routing and remote access servers to provide connectivity between the different networks. Each network will also incorporate 2 domain controllers with DNS and 2 DHCP servers. The reason we use 2 is to provide fault tolerance. The DHCP servers will be handing out IP addresses, which Michelle will explain, using an 80/20 scope, and they'll also be hosting the file print application services as well as the update services and WINS. So all that are going to be on these machines within each network. Inner organization looks kind of confusing, but basically we're getting connectivity using a persistent demand dial connection from one network to every other network. So that's our result. We're utilizing a virtual private network to use the internet structure that's in place instead of physically running cable from each location, which would be almost impossible. It's not only more cost effective, but it's also more efficient, and it provides fault tolerance if one week were to come down. I'll be followed by Michelle, who will further explain our DHCP scope.
Thank you, Ben. We are using DHCP because it configures hosts on a TCP IP-based network. It automatically assigns IP addresses to make the management of IP addressing easier. Our scope is 10.10.x.0/20 for our private address. We are using 1 through 9 for our routers, switches, and access points. 10 through 19 for our printers, for our servers, which we will be statically assigning. 20 through 49 for our printers, which will be using reservation. 50 through 99 exclusion. That's for just in case for growth. And then 100 through 254 is our workstations, which we are using the 80/20 scope, as been mentioned. 100 through 199 is our 80%, and 201 to 254 is our 20%. Our public address and also our default gateway is 192.168.x.0/24. I will be followed by Glenn, who will be talking about our RAS.
We will be deploying an RS server in each domain. RS is a software router and open platform for routing and networking. It offers routing services in local area and wide area networks, as well as over the internet via virtual private network, which we will be utilizing as a SOC. It also provides NAT, which is network address translation. The advantage of this is it provides basically a basic firewall because there's one access point to the internet for the entire network. And as somebody comes in, it's translated, you go to this user, it has a table in there to translate that to an internal address. Just an extra layer of security. Plus it helps the firewall work better with the NAT, which we can talk about later. We will have remote users using VPN to come in because we do have mobile notebook equipment. We do business in 10 countries. So we're going to need that. We're going to use MS Chat v2, primarily because it is the highest level of encryption that is still compatible with any legacy operations. If we were to go to an EAP, that's mainly for smart cards. We're not there yet. We're using passwords. So we're going to stick with an MS Chat v2 and password authentication, as I mentioned. Now Dominic will address DNS.
Thanks, Glenn. First of all, we have, like Ben said, we have 2 DNS in each domain, for redundancy. In this case, one were to go down, we'd have a second one as backup. And WINS would be on one of the DHCP servers. And WINS will just cover the name resolution and legacy programs and operating systems. The trust is inherited from the parent to the children domains on both floors. So we had to create a trust. We will create a trust between 2 parent domains. They can communicate. It's a little confusing as well. The replication. First the primary zones within our own forests, and then we created subzones from the child domains on one forest